Hello, welcome to A Moment of Science, Please. I'm one of your hosts, Margarita.
And I'm your second host, Ana.
Today, we have Dr. Jenna Gillen on our podcast, who is a professor of kinesiology at U of T. Welcome, Dr. Gillen.
Hi, thanks so much for having me.
Lovely. So, jumping into our first question, we were wondering if you can please introduce yourself for our audience and let us know more about your background and education.
Sure. So I am currently an assistant professor in the Faculty of Kinesiology and Physical Education here at the University of Toronto. I teach and do research specifically within the area of exercise physiology. And so I have a couple of different courses that I teach at the undergraduate level. And then I run a research lab where we try to understand how exercise and nutrition alter aspects of carbohydrate and fat metabolism in humans. And we also try to identify ways and strategies that exercise and nutrition can improve aspects of our metabolic health. And so this research really involves human participants. We do some invasive measurements like blood sampling, or we take muscle biopsies as well to learn a little bit at the molecular level what's going on in response to our interventions. But we also do some other exercise testing, measures of body composition or strength, monitors or wearable apps that we can use that measure heart rate and some other physiological responses. But the key aspect is we bring, under normal circumstances, human participants into the lab to see how their aspects of their physiology respond to interventions like exercise or nutrition. And so I think you asked a little bit about my education as well. So I did most of my schooling at McMaster University in Hamilton. So I did my undergraduate and I did my graduate studies there as well. So I got my PhD at McMaster. And then following my PhD, I knew I wanted to continue and pursue academia, hopeful of getting that academic position. So I went to the US for my first postdoc at the University of Michigan, where I continued to study carbohydrate and fat metabolism, but specifically within obesity. And then I did actually a second postdoctoral fellowship at the University of Toronto, which was right prior to getting the appointment as an assistant professor.
Lovely, very long history of
Yes.
education, and it's really cool. The topics you're focusing on, they're really relevant to our lives today with all the diabetes and obesity pandemic. So very lovely research. We're so excited to hear more about it.
Yes, thank you.
Really rich academic background. It was really interesting. So as a follow-up question, for everyone who's not overly familiar with the field of kinesiology, can you please let us know a little bit about research in this field?
Yes. So yeah, kinesiology, it's a very multidisciplinary field. And so within our faculty of kinesiology and physical education here at U of T, we have a very diverse group of academics that research in all different fields, such as the biological sciences like I do, but also people in more the social sciences and humanities aspects of kinesiology. And so I think, kinesiology can often be defined or referred to as the study of human movement, but that is quite broad. And so if we break it down, there's a wide range of topics researchers can be interested in. And so within our faculty, for example, we have experts in biomechanics, motor control, as well as health or sports psychology. We also have researchers that look at more sociocultural aspects of sport and factors that may influence sport participation among youth or adults as well. And so it can be quite broad. My focus is within the exercise physiology realm, where we try to understand at both the whole body, the molecular level as well, in different tissues, what's going on in response to exercise and nutrition interventions. And so we're really interested in the basic science of the physiological responses the body has to perturbations like exercise, whether it be high intensity exercise or moderate intensity exercise, whether it might be endurance exercise or resistance style or strength training. And we're also really interested in the health benefit that these interventions will provide. And so we'll take those biological measurements to try to get insight into that. So those would be kind of many of the key areas of kinesiology, but I think one thing is there is know just one specific area of kin. It can be very broad, and it can certainly vary at each university as well, where they might have different expertise within their faculty. And we're really lucky at U of T to have so many academics with really research specialties in such different areas of kinesiology. So we're very multidisciplinary, and it allows us to collaborate as well and get greater, learn more about the interventions that we're doing. So I could collaborate, for example, with people in health psychology and to see if the interventions we're doing that show beneficial effects at the physiological level. Well, then we could also investigate, well, do people enjoy this? Will they adhere to it? Will they actually perform this intervention in the real world? So I will lean on my colleagues in that regard to try to round out our interventions as well.
Wow, kinesiology is like really huge field. So, and we were wondering, how did you choose your area of study among these multi like broad spectrum
interdisciplinary as well?
Yeah, it can be challenging for a student in kinesiology, actually, because you start in first year, you get exposed to the different areas. That's typically the way kinesiology is set up, that in your first year of your undergraduate, you'll be exposed to the different areas of kinesiology. And so I took a course on the history of kinesiology. I also took anatomy and physiology. I would have had motor learning and motor control. In your second year, you get exposed to courses like biomechanics as well. And exercise physiology was the specific second year course that really caught my eye. And so again, this was at McMaster University. I was in second year. I had a fantastic professor who really sparked my interest in the topic of physiology. I was always someone really interested in exercise as well as nutrition, but I played sports in high school. I was interested in physical activity. And I also really like sciences. I enjoyed biology and chemistry. And so seeing the combination of those basic sciences and understanding how systems respond, and then also applying that to exercise, it seemed like a perfect fit for me to try to understand what's going on in the body in response to exercise. And so I really enjoyed second year physiology, and that's when I decided in my third and fourth year, I'm going to take more courses within that field. And that's typically where kinesiology students can branch out. So if they decide I really am interested in the sociocultural aspects of kinesiology, then they're going to be able to have more choices in third and fourth year to take those courses. And similar, if you're interested in biomechanics or more of the sports psychology, you can kind of specialize at that point. And so I made the decision to specialize more in the physiology as well as nutrition courses. And I got involved in research. And so that professor that taught second year, I continued to take his upper year course as well. And I approached him about working in his lab for the summer. And that's really where things started. It was at the end of my third year. I worked in his lab for that summer. I got to learn a lot of wet lab skills on human muscle samples. So we did techniques like Western blotting to measure proteins of mitochondria, for example, that might respond to exercise training. And I just thought it was so exciting. We also were looking at some health outcomes at a similar time, a type of exercise. His lab, this is Dr. Martin Gawala at McMaster University, really focuses on high intensity interval training. It's a time efficient form of exercise that's been shown to lead to a lot of the same physiological adaptations that we normally associate with higher volumes of exercise, like going for a 60-minute run or 60-minute biking, more at a moderate intensity. And so his research was really one of the first to be exploring the impacts of more time efficient but high intensity exercise strategies, which are of course quite popular now. A lot of individuals are interested in the idea of high intensity interval training. As one of the perks is it's time efficient, but has still been shown to lead to a lot of the same physiological adaptations in muscle, as well as some of the same health benefits. And so that really I thought was fascinating. I kept continuing within his lab, working there, doing an undergraduate thesis as well in my final year, my fourth year of kinesiology. And then I started a master's, and then I continued and kept going on with the PhD in his lab as well. So I caught the research bug early, I think, and that's what made me continue specifically within that field.
Thank you for sharing how you discovered metabolic and physiological aspects of exercise and your experience, how you involved in the research is really interesting, and I'm sure it will intrigue other students to be more involved in the research.
Yeah, this is definitely what we're trying to highlight to undergraduate audiences here, that you can get into research early and you can succeed and make a career out of it, especially if you find something that sparks your interest quite early on, which is, I think, is so lovely. You found something that you were interested in, not after
Yeah.
like fourth year or after a master's or a PhD. You found it in second year, which is so amazing. So
And yeah, I think it really helped me figure out what I wanted to do after undergrad. Not everybody has a plan. I didn't. I had some ideas. I think like many people that go into kinesiology, they think they might, go into physiotherapy after, or occupational therapy, maybe med school. And these ideas floated around, but I was never set on one thing. And I think it was just getting involved in research. It was my aha moment. This is, what I want to keep doing. And if I hadn't have gotten involved in second year, or at the end of my, I guess after the physiology course, the first time in this lab was the end of my third year. But at that time, in approaching the professor, I probably wouldn't be here today. So it certainly was a monumental moment and definitely career deciding for me, but I didn't know at the time. I was just pursuing what I was interested in. And like I said, I was passionate about it, caught the bug and kept going. So certainly would encourage that if you're interested in an area of research to try to get involved as much as possible.
yes, see, I know a lot of undergrads, they're intimidated by approaching a prof that they're in, whose research they're interested in, usually because they think, oh, they don't need me, I'm not qualified enough. There's like a whole list of reasons, but you clearly show that it is possible to get involved in research which you're interested in. So definitely, I think it's a note of encouragement that every undergraduate student needs if they're interested in research. So on to our next question. This is going to be jumping in more so into the paper that we wanted to discuss with you. So you're the first author on the paper, interrupting prolonged sitting with repeated chair stands or short walks reduces postprandial insulinemia in healthy adults. Given the effects of the COVID-19 pandemic on the lifestyle of people, especially students, can you let us know why you decided to do research on this topic in the first place? So this paper is from 2020, so it's definitely, I'm sure, had a lot of impact on the lifestyle, or it was a really relevant topic in 2020 and 2021 as well.
Yes, thank you. Yes, it was relevant. I think we've all been spending more time sitting in prolonged periods of sitting, unfortunately, with shelter at home guidelines. But the backstory for this, we conducted this study prior to the pandemic. So this intervention required human participants to come to the lab. We took blood samples throughout the day. And so this, of course, wasn't possible over the past year. Our lab, unfortunately, has been shut down and we haven't been able to have human research participants in the lab. So this study was done prior, but as you mentioned, was very relevant for our current lifestyle, unfortunately. And so we know physical activity is really important. It's beneficial for people's metabolic health, but we know not everybody meets physical activity guidelines. And we also know that sometimes people that do meet physical activity guidelines, maybe they do it all at once on the weekend. So the idea of the weekend warrior, or they might be more active on the weekend, but then they still spend a lot of time sitting Monday to Friday. You've mentioned students, they'll spend a lot of time sitting, studying, watching lectures. It's unfortunately ingrained in a lot of our modern lifestyle, whether we're commuting in a car or on the subway, or if we're working or in school, or many of our pastimes, whether it be reading or watching TV, a lot of it involves sedentary behavior. And so unfortunately, we know that can be associated with health complications and future risk of disease. And so we want to avoid these periods of prolonged sitting as best as we can. And so research has shown that if you can break up periods of prolonged sitting intermittently, so maybe every half hour, maybe every hour. So if you were sitting all day while studying, for example, it can be associated with some health benefits as compared to if you just sat for a very prolonged period of time. And so the breaking up sitting, previous research had focused on walking breaks. So if you sat all day, just every 30 minutes, setting a timer idea and going for a 1 or 2 minute walk. So something very quick, but just to get your body moving and intermittently break up that period of prolonged sitting. And one of the key outcomes that is often looked at is your blood sugar regulation. We know that inactivity as well as sedentary time can be associated with high blood glucose concentrations, especially following a meal. So often when we're sitting, we also eat, especially if we're maybe doing a pastime like watching TV, and of course, if we're studying as well. And so we know that when we consume a meal, particularly a meal with higher carbohydrates, it'll increase our blood glucose concentration. And this signals the body to release the hormone insulin from the pancreas, which is what helps get that glucose into our peripheral tissues. And so one of the key tissues that takes in that glucose following a meal and is very responsive to the hormone insulin is our skeletal muscle. So we have a lot of muscle in the human body, and it's one of the largest sinks or reservoirs for that glucose to go. And so we want it to get into our muscle following a meal rather than accumulating in the bloodstream. As we know, that can be associated with diseases like prediabetes and type 2 diabetes, which are associated with high blood glucose levels. And so unfortunately, if we're just sitting all day and consuming high carbohydrate meals, research has shown your spikes in blood glucose as well as blood insulin to help control that can be higher. And so we were interested in, can we see if these postprandial glycemic excursions and insulin excursions can be reduced if we break up that prolonged sitting with the very bite-sized amounts of exercise. And so this field has been referred to as the idea of exercise snacks as well. So they're very bite-sized snacks. It's not like a full exercise session, but really snack-sized. We were interested in the walking, but we were also interested in a form of body weight exercise that didn't require you to, get up from and leave your desk. For example, the walking interventions, if you think about it, you'd either have to go leave your desk and walk somewhere, or have a treadmill right beside your desk, which is what a lot of the research studies used, which isn't necessarily practical or reflect what many people have beside their desk or at the library. And so we wanted an intervention that could maybe still achieve the same benefit, but one that didn't require additional space, it didn't require additional equipment, and could be done right where you are. So maybe you're someone who works on the phones, for example, answering phone calls. You can't necessarily leave your desk for a 2-minute walk every 30 minutes. And so we tried to come up with a more accessible option. And so it just involved repeated chair stands. So it's like a body weight squat, but you would get up off your chair. You would actually do a calf raise at the top, so just standing on your tippy toes, and then you'd come back down to sit on the chair again. And you would just repeat that 15 times in the span of 1 minute. And so we had participants do this 1 minute exercise break of repeated chair stands every 30 minutes over the course of our 7-hour day that we had in the lab. And it was a within subject design. They either sat all day on one trial, on another trial, they broke that sitting up with the repeated chair stands idea, or on another trial, broke it up with the walking. And we found that the insulin concentrations were lower following exercise, or when we did those exercise snacks throughout the day. I think we might get to that with your next question, but overall, it seemed to be rather relevant given the timing of the COVID-19 pandemic.
Absolutely. This sounds like such a practical exercise method. Definitely much more realistic, I think, for people than going for a run, even for 15 minutes. Something like this, most people may not have time for, but especially the chair squat stands, those sound absolutely reasonable, realistic, and I think I might be incorporating them into my routine as well, because it's just so practical. So
absolutely, it's something I try to do on the regular as well while I'm cooped up here in the office at home. It's a great way to break up the prolonged sitting.
I really hope the students will take your research paper in mind when they're gonna study for exam next time.
Absolutely.
So in your previous mentioned study, you hypothesized that postprandial glycemia, and insulinemia would exercise a similar reduction, would experience a similar reduction when sitting is interrupted by short exercise breaks. We were wondering how you came up with this hypothesis and if there was a mechanistic basis for this hypothesis.
Yeah, and so building off that last question, so we did hypothesize that these exercise snacks would help lower our blood glucose as well as blood insulin concentrations throughout the day, because we were also feeding our participants. We gave them a breakfast and a lunch while they were in the lab all day, again, to try to mimic real life. They were mixed macronutrient meals, similar in profile to what someone might eat. And so there are a couple of ways that glucose can get out of the blood. One is through that hormone insulin. As I mentioned, insulin is very important in promoting glucose uptake into tissues. And the other way we can also get glucose into skeletal muscle in particular is by contracting it. And so skeletal muscle requires glucose for energy. It can also use fatty acids for energy, but we like to use carbohydrates for energy, especially if they're within the bloodstream. And so when we contract our muscles, it actually signals glucose to be taken into skeletal muscle in a mechanism that's independent from insulin. So it's more of a contraction mediated pathway that causes glucose to get out of the bloodstream into skeletal muscle so it can be used for energy. It can also be stored there as muscle glycogen. And so the hypothesis was really with the idea of, well, we know when we feed these participants the meals, their blood insulin concentration is going to go up to try to control that carbohydrate and the glucose in the bloodstream. But if they contract their muscles, as opposed to just sitting there for a prolonged period of time, that also creates another system or signal that could bring the glucose into skeletal muscle and therefore lower it within the bloodstream. And so our hypothesis was with that idea that we would activate the contraction-mediated glucose uptake pathway in addition to the insulin-mediated pathway, which would be occurring following the meal. And so that was the general idea. And we originally did hypothesize that we would see a reduction in both glucose as well as insulin over the course of the day in the 2 exercise snack interventions.
Wonderful, thank you. That is a very clearly explained hypotheses, because sometimes when you do read papers, the authors say, oh, we hypothesized this, and you're just like, why though? Because a lot of them don't explain, or maybe again, this is an issue with like our life sciences field. Sometimes you do get very complicated hypotheses, which do need a really good foundation of the field. So thank you so much for explaining it. It definitely makes a lot of sense now, and it's a good, like, clear mechanism for it. So our next question was about one of your findings, and it was that one of your findings found that insulin levels are reduced in individuals who either had squat or treadmill walking interruptions in their prolonged sitting. So can you please explain the significance of this finding?
Yes, and so our hypothesis was that both glucose and insulin would be reduced, but in the end, we only saw that insulin concentrations were reduced by the exercise snacks, which upon reflection and further thinking about it afterwards, given the population we studied, I think these findings really make a lot of sense. And so I didn't mention earlier, but the participants that we brought into the lab were relatively healthy. They weren't individuals that had prediabetes or type 2 diabetes. They were relatively healthy, young adults, and both males as well as females, who didn't have any disease or history of poor glycemic control. They weren't meeting physical activity guidelines, but they weren't completely sedentary either. They seemed to be just typical healthy young adults. And so one of the first signs of impaired glycemic control is a higher insulin concentration in response to carbohydrate. And so these individuals didn't have poor blood glucose concentrations when we analyzed it. Their blood sugar responses were quite normal in response to the meals that we were giving them. They certainly didn't go too high into hyperglycemia. But in some of the individuals, their insulin concentrations were quite high in response to the meals, especially when they were doing the prolonged sitting intervention. And typically what we see with insulin resistance or the progression to poor glycemic control is insulin concentrations tend to be higher first. So that's typically what one might see as a first sign of poor glycemic control or insulin resistance, is that the body needs to produce more insulin to clear the same amount of glucose. So the body's really good at, if you're starting to develop some insulin resistance, which is an underlying problem in prediabetes and type 2 diabetes, where our peripheral tissues just don't respond to the hormone insulin as well. And so we don't get as much glucose uptake. the body is pretty savvy and it'll just release more insulin. And so then we now have more insulin to clear the same amount of glucose. But unfortunately, that causes the pancreas to work harder, and it can result in hyperinsulinemia, which is also associated with some health complications. And so we found that when we were more active throughout the day using these exercise snacks, the blood insulin concentration was lower. And so I think that's significant because the muscle was taking some of that load, and it was contracting and drawing in more glucose. And so the body didn't need to produce as much insulin to clear that amount of glucose, which is a beneficial response.
That was really interesting to know more about how this strength meeting can benefit the body in terms of glucose level. And we were wondering, as a follow-up question, almost all studies have possible limitations, and therefore their results should be interpreted carefully. Can you talk about some of the possible limitations of this study and how they can be accounted in the future?
Yes, you're absolutely right. All studies have limitations. We're not going to close the loop, as we would say, with one study. And I think that'll mean there's always more research that needs to be done, which is a good thing for people like us that are interested in science. So one of the first key limitations was it was a small study. In our type of interventions in kinesiology, it's not uncommon to have small sample sizes, between 10 and 20 participants. It's quite invasive what we do. We take lots of blood samples. We also took muscle biopsies in this study. Our trials are very long. They can be difficult studies to run. And so unfortunately, we'd love to have more participants, but they're often small. And so we would call this more of a proof of concept, small study, not a full clinical trial, but certainly we need more studies like that do a more rigorous evaluation using clinical trial rules, and actually with a larger sample size, see if these results hold up. But our small study, it was, I believe, 14 participants who completed all 3 interventions for us. So small study would be one key limitation. Another thing that comes to mind is it's only one day. So this was just the response to one day of the exercise snacks. I think you could argue, well, that's great if people just want to get a quick fix and something that will be beneficial one day can make a difference. I think that's a really important message, that you don't need to do just exercise training for weeks or months to get a beneficial improvement in your blood sugar regulation. You can get the benefit over one day, but what happens if you do it regularly? Do the benefits continue? Can you get some sort of chronic adaptation if you do this more regularly? So I think that would be something to explore further, and something to keep in mind, that it is just one day. If they go back to sitting the next day and aren't doing the exercise snacks, you'd probably think, well, then their blood sugar won't continue to be improved.
Well, oh, sorry, go ahead.
Oh, no problem. I was just going to say one other thing is that another aspect is trying to understand the mechanisms a bit more. And so we took muscle biopsies, but they were at the end of the day in the participants. So it would be maybe valuable to try to get an idea of what's going on in the muscle during the day when they're actually participating in the exercise snack. So we're interested in some of those questions as well. And then the other aspect, will people do this? And so for more behavior change, colleagues and individuals interested in looking at interventions in the real world and maybe taking this out of the lab and doing it at home, is this a feasible and realistic intervention for people? I think some people think it's easy and could add it in, but I think we need some studies to determine that for sure.
Wonderful. Thank you so much for sharing limitations and possible future research questions. Often limitations are sometimes difficult to identify because you kind of struggle past the setting up of the perfect protocol technically, and thinking that it might have a limitation is a bit counterintuitive. But thank you so much for identifying some of those. It's definitely a very important skill in research to be able to do this. And the future research questions sound definitely very interesting. So looking forward to some more papers from you on that. So the next question that we had, it's not related to the paper, but do you have any tips or advice for undergraduate or any student really that is interested in getting into research?
Yes, and I think, one of the key things is what we touched on earlier, is try your best to get involved in your undergrad, to identify if it's a area you want to pursue. So I would really encourage you to reach out to professors if you know they have a research lab. Most professors are very happy to talk about their research. They'll talk for hours on end. And so don't be afraid. Many professors are here to offer research opportunities for students, including undergraduates. And I know I get a lot of joy out of offering those research opportunities for students and seeing their passion for research develop, just like mine did as an undergraduate. I would also encourage you to talk to graduate students or maybe TAs that you have who have experience with research to learn a bit more, if you can, about what that is like for them, because a lot of them, maybe fell into it as well in their undergrad, and one email or one conversation with a prof really made a difference for them getting into graduate studies. So really try your best to get out there and ask questions, and you don't need to just stick with professors within your own department. And so students in life sciences in particular, they may have a lot of personal interest in exercise and nutrition, and maybe looking at professors within kinesiology who look at exercise physiology or metabolism in response to nutrition, like myself and other colleagues of mine do, might be a very good avenue for you to explore as well. A lot of the analytical techniques you might do in molecular biology or any courses within the field of life sciences, we also do in kinesiology. It's very much like a biochemistry lab, but we work on human samples of muscle as well as blood sampling. And so if that's something you're interested in, you can always try to look a bit further outside and see if there's other opportunities as well. And I think it's just great to get involved in research early, as there's a lot of different things about research to learn, whether it's the analytical techniques, but also a lot of the professional skills like teamwork and organization, critical thinking, all the interpersonal skills that you develop. I think, whether you continue in research or not, those are really important skills for a lot of professions. So I don't think you can go wrong in trying to get involved in research young.
Absolutely. I couldn't agree more with that. Personally, I obsessively email profs. It's something that you got to do. And the TA hack absolutely works. I know so many people that got into the lab, for example, that I'm working in through their TAs. So everything you said is definitely very true. And I think the fact that you said it brings you joy to have undergrads like join your lab, I think this should be a sign of encouragement, because again, it kind of reduces the intimidation of trying to contact a prof about this.
Thank you for sharing encouraging notes for the student to get involved in the research. I couldn't agree more, because I get into research because with the encouragement from upper year students. And now we would like to finish our podcast with a question that we always ask our guest speakers, which is, who is your favorite scientist and why?
Yeah, that's a good question. It's not something I spent a lot of time thinking about. I admire many scientists, many that I don't know, many whose work that I have read, giants within my field, as you might say. I admire many of the people I've worked with as well. Many of my mentors are fantastic scientists. But I think for this, I'll give a nod to Frederick Banting and Charles Best, who discovered insulin here at the University of Toronto in 1920. So given it's, in the 1920s, so it's, the 100th anniversary of that invention of insulin and identifying it. And given that they were at U of T and the theme of this work was insulin, I think those are two very important scientists to mention.
Absolutely. It's been such an important contribution. Obviously, diabetes used to be a death sentence. Thanks to them, it's no longer that. And thank you for mentioning it. These scientists, I think everyone kind of has them at the back of their mind, but we definitely have to acknowledge them. Thank you for sharing.
Yeah, thank you so much. So with that, Dr. Gillen, thank you so much for coming on today and sharing your research with our audience. It was a pleasure to talk with you. This concludes our podcast. Thank you everyone who has joined us. If you found this podcast engaging, keep an eye for our next episode, and don't forget to subscribe to us on YouTube and follow us on social media.